you conduct a tonnage measurement in the plant, basically you need to have a flow meter at the pipe side. As what Kenji said, you have to remove the insulation and do the flow measurement, and you have to know the delta T measurement, chill water supply and chill water return. So you see, when you use just a simple measurement, you will have ended up in a lot of sensor errors. Like say, if you're using a temperature sensor of plus minus 1 degree C, two sensors, right? Your possible error can be 2 degrees C, right? So that's why when you engage the right consultant or right auditor, they will normally use a very accurate sensing points, no? So you will see that if the design delta T is 10 degree F at 5.56 degrees C, you are looking at an error of 36% error. If you are not using a proper measurement, then the error measurement can be a lot, you know. So normally we will use thermistor probes, which are the plus minus 0.01 degrees C. So two sensors, right? Possible error is only 36%, right? So for the initial one, you can just base on this, and then when you know there's a potential of big saving, then you must engage right people with the right tools to do all this measurement works. So most of the places you see, sometimes you see in the chiller plant, you'll see a chiller's pipes, they are closed halfway or 45 degrees close. So this is, they are using a throttling method, no? So that's why we are using for pumps, use a variable speed drive, which is very commonly used. You can see here, if you use a 100% flow, you are using almost 25 kilowatt. This is an example. So if you're using a throttling effect by bringing it down to 60% of the flow, you're looking at 20 horsepower, right? But when you're using a variable speed drive, you're using 10 horsepower. So that's a difference, right? So if you see any throttling method is being used in your plant, you should avoid using this throttling method and look for the variable speed. You can also use this for your air handling side, where you see dampers are being used with what you call throttling, where you control the amount of air which is going down to the ducting. All this you can use a variable speed drive to control the right amount of air, right? In any plant, shouldn't use any throttling method, which is a waste of energy. So on the chiller plant, we also can look into the approach temperature, right? Approach temperature is a wet bulb temperature against this inlet water temperature of the cooling tower, which is coming out from cooling tower, which is like over here is like 29 degrees C, which is coming out. And you see in most of the places, right, cooling tower is something that is not many people bothered to look at it, because it's an outside of the building, and normally they are just looking the chiller, how efficient the chiller. But you see, cooling tower brings a big impact to the efficiency of the chiller. The lower you can bring down the cooling tower temperature, the more efficient your chiller will become. So you'll have a major saving in that. So you can also measure your outlet temperature. What is your condenser water temperature like? Is it 29, 30 degrees or 31 degrees? So how much can it go down is based on what is your wet bulb temperature of your current location. Roughly 2 degrees above the wet bulb temperature should be your condenser water supply temperature. Sorry. So for chillers, right, basically that's all you can do for chiller plant. Basically improve the system efficiency to bring down, and this will give you the major saving in any building, right? So now we go into a simple explanation on a compressor system. So compressor system is also same like a chiller plant. It's a whole system which compressor plant produce compressor air and used on your product side, demand side. So you see the transmission, right? You have a pipeline transmission. You can actually recover the pressure losses along the pipeline and use if more efficiently the use of the air. So in compressor plant also, plant owners or plant engineers can do a initial first check by doing a leak test analysis in your plant, right? uh, Leak test, you don't need a big time expert to come and do your leak test. You can just go around the plant and resolve your leak test, you know. So leak test, sometimes you will see the hissing sound everywhere. You should put in an effort to make sure there's no leaks in the plant, right?